Good afternoon, everybody. My name's Sarah Bell and I am your chair this afternoon for the final in our series of events celebrating 55 years of environmental design and engineering at UCL. We've had a wonderful set of presentations by our panelists this week, and now this is an opportunity to get them all together to look at some of the cross-cutting themes and for you to ask questions that might come up from what you hear today, or also that you may have pondered during the week based on your tuning in to some of the other presentations. So I am Professor of Environmental Engineering in the Institute for Design and Engineering. My research focuses on urban water systems, and in particular, I have a research interest in community engagement with infrastructure. But I am the least interesting person on your screens today. And so it's my pleasure now to start to introduce our panel. The format for this event will be that I will introduce each of the panelists in turn, and then they'll just give a quick headline synopsis of the key message from their talk during the week. Then we'll start off just with a round of questions to warm things up. And for all of you, please start putting those questions into the Q&A box. So yeah, I'll then be able to direct your questions to individual panelists, and also feel free to ask questions for all of our panelists to comment on, because that's one of the great benefits of this format, is to get so many different points of view. So our first panelist today is Claire Heaviside. Claire is a NERC Independent Research Fellow and will become Associate Professor at UCL in the Institute for Environmental Design and Engineering. So she's currently funded by NERC, and that will transfer into an academic appointment in 2023. Her fellowship research, which she's dedicated to at the moment, investigates the impact of urban heat island on health using atmospheric modelling and health impact assessment. So Claire, what was the headline message from your presentation this week?
Okay, so to summarise in a minute, so I talked on Monday about how climate change affects health through numerous different exposure pathways, and I gave a few examples of how climate change might change the balance of heat and cold mortality in the future. And I talked about the importance of the urban heat island in relation to excess heat exposure and the vulnerability of urban populations. I presented results of regional climate modelling on how we may be able to reduce mortality associated with the urban heat island, compounding events like heat waves and air pollution events, which happen sometimes at the same time. And I suppose the bigger picture was that although we can model the kind of environmental risk factors in the physical environment fairly well, and we can carry out health impact assessment, we need to also take account of things like demographic and socioeconomic and environmental factors to get accurate assessments and to be able to address the potential impacts on health.
Thank you, Claire. Our next panellist is Mike Davies. Mike is Professor of Building Physics and Environment here in the IEDE. For more than a decade, Mike's led an extensive program of research founded on intimate collaboration with researchers from health and other disciplines. So that's brought him into an understanding of the complex relationship between the built environment and human well-being. And in particular, his collaboration with Paul Wilkinson, who's Professor of Environmental Epidemiology at the London School of Hygiene and Tropical Medicine, has been a very productive interdisciplinary collaboration, which has been the foundation of many strong research projects, including the project that you spoke to us about on Monday. So Mike, tell us, what was the highlight of your talk earlier this week?
Thank you very much, Sarah. Yeah, so in my talk about sustainable and healthy cities on Monday, I noted that urban populations throughout the world really face the challenge of needing to address local environmental imperatives, but also taking action to safeguard planetary health. And I mentioned three interlinked challenges to building sustainable cities. Firstly, reducing the environmental footprint of cities, and secondly, increasing their resilience to environmental change. But vitally and very importantly, and in an integrated way, promoting and protecting health. And really, by almost any measure, success in meeting those key environmental and associated health challenges has at best been rather limited. But we know that there are potential substantial benefits from climate action, not only because of the benefit of reducing future impacts of climate change, but also because of the more immediate co-benefits for health of the transition to a low carbon economy. So the project you mentioned, the Complex Urban Systems for Sustainability and Health, CUSH, funded by the Wellcome Trust, is aiming to, or is attempting to support cities in bringing about citywide changes with the aim of transforming environmental quality, sustainability, population, health and equity. And we believe that three components are vital to help push that forward. The provision of cutting edge scientific evidence, but done within a framework of participatory engagement and research with the stakeholders in the cities. But thirdly, and very importantly, recognizing that cities are complex systems and dealing with that complexity in a formalized manner is, we believe, essential to be able to pull together those components in a way that would be useful for policymakers. So yeah, thank you very much indeed. That was a talk in a nutshell.
Thanks, Mike. So the next person up on our schedule this week was Florence Lamb. Florence is an ARUP fellow and she leads ARUP's global lighting design practice. She has a number of executive roles in the UK IMEA region, including her role as ARUP University leader. Florence's particular expertise is in daylight, visual perception and holistic lighting approach. And this has played a key role in many projects from museums to airports, bridges and city precincts all over the world. Florence was responsible for delivering a range of lighting projects for the 2012 London Olympic Games and has a strong interest in visual light art as a designer. And she's collaborated with a number of artists and architects on public realm projects, including Anish Kapoor's the ArcelorMittal Orbit in London, the world's largest timepiece in Zurich, and the Dongdaemun World Design Plaza in Seoul. So Florence, what was the headlines from your talk this week?
Thank you, Sarah, for the introductions. So my talk was called Lighting for Humanity. It calls for a new approach on sustainable development. Because if we were to achieve the lasting positive UN SDGs outcome for society and our planet, we really need to go beyond the current practice of sustainability, which is mainly focused on limiting consumption and damage, but work more towards the regenerative design, where the built environment is conceived and designed to facilitate the symbiotic relationship between human, our activities, the physical and ecological systems. So in my talk, I also explore three aspects through the lens of light and lighting: the human perspective to improve health, safety, and well-being from day to night, the ecological consideration in our design beyond mitigation, but also the circular design approach. Because we know that depletion of carbon has been the root cause of many global challenges as a result of climate change and biodiversity loss. But the drive towards improving energy efficiency coupled with the switching to renewable energies are already playing a vital role in reducing the operation carbon. However, these alone just will not be enough. So what I've been saying is also in order to achieve the UN climate targets, it is crucial for us also to transform how we design, how we specify, make and use products. So that's about my talk.
Great. Thanks, Florence. Our next speaker is Esfan Berman. Esfan was the lead field investigator for building performance evaluations in several educational buildings funded by Innovate UK and the Engineering and Physical Sciences Research Council. The projects involved detailed and long-term energy performance analysis, monitoring, and also analysis of the indoor environmental quality, operational compared to design performance review, and building use studies. S-Funds also contributed to other Innovate UK projects funded under the Building Performance Evaluation Program, including post-occupancy evaluations of various buildings, such as the Pool and Tremau Innovation Centres, Centenary Quay Development, and a carbon buzz metadata analysis. S-Fund joined the IEDE as a research associate in complex built environment systems in 2014, and he is now a lecturer in the institute and has worked on projects including the total performance of low carbon buildings in China and the UK, which was funded, the UK component, by the EPSRC. So Esfan, tell us about your talk this week.
Thank you, Sarah. So my talk was related to a new technical memorandum that we published with the Chartered Institution of Building Services Engineers, CIBSE, TM61, on operational performance of buildings. The aim of this publication is to address the problem of the performance gap, significant discrepancies very often uncovered between actual operation of new built buildings and design aspirations. In terms of energy performance gap is very well known, but also, and crucially important in this context, indoor environmental quality and the link between performance gap in IQ, indoor environmental quality, and underperformance in energy consumption and energy performance. So this intricate relation between energy and IQ was at the heart of our research. You referred, Sarah, to the top project, total operational performance of low carbon buildings. Over the last few years, we have conducted several research projects that informed this publication, TM61, but TOP was probably the most important one, and the case study presented in this technical memorandum were informed by the TOP project. I gave only one example to highlight the problem of potential conflicts between energy and IQ, and that was the problem of indoor sources of pollution and their impact on indoor air quality in new built airtight dwellings that have energy efficiency measures, and this can have knock-on effects in terms of indoor air quality. And what is the best way of addressing this issue and mitigating the impact of indoor sources of pollution? The so-called source control measures and enhanced ventilation as a supplementary measure. That was only one example, but then the talk moved on to basically explain other potential issues, but also mitigation measures to close the performance gap.
Thanks, that's fun. And excuse me, next up we have Ian Taylor. Ian has done a lot of work in the education sector over the last 10 years, including the design of 6 REBA award-winning schools in London and the Southeast, and university and academic residential projects for Queen Mary University London, I need to get that right, the LSE, University of Southampton, and the University of Washington in Seattle. Ian has contributed to the recent CIBSE publication on integrated school design and has supported the development of school-specific post-occupancy evaluation methodologies. Ian, tell us about your talk.
Thank you, Sarah. Yeah, the fact that this is the 55th year of the Institute made me think about reflecting on where we are now compared to where we were 55 years ago, which I discovered was when the Beatles released Help. And a few years before then, I found an architectural design magazine that had examples of passive solar design, adjustable solar louvers, 3 fantastic examples of laminated timber construction, companies making these components in the UK. And at the same time, the Petroleum Institute were being warned that the outcome of their the use of oil could have significant CO2 impacts on the environment, which could cause serious threat to people. So what has been happening in the last 55 years was what I was thinking. Why have we moved so slowly? And the fact that the climate emergency has now made many more people aware of the urgency of change. The architectural profession seriously has to change their attitude to work. And so the issues that I then looked at were sort of 4 stages of change that have to happen within architectural practice. Firstly, to decide to realize there's an issue and commit to making a difference. To then understand the issues that have to be dealt with and prepare ways that you can design to achieve those changes. Actually act and carry that work out in a different way. And then share the results if there's good information to share. I think it's absolutely imperative that there's real collaboration between disciplines and between academia and practice. And we are at a pivotal point where the Institute should have much more influence in the future. Thank you.
Thanks. And finally, someone who has joined us in place of Ashley Bateson, who spoke on Wednesday. And I'm going to make an apology for my very unprofessional preparation for this event, having running late from various events this morning, is that I didn't check, my Irish pronunciation isn't the best, and I didn't check how to pronounce Ima Maloney's name. So please, first of all, correct me. Nothing like that?
No, it's not too bad. It's Emer.
Ema. Oh, in my head, I was trying to come up with different. Anyway, Ema.
That's okay. That's all right.
Good. So my apologies.
Yeah, I can
Ema.
introduce myself. It's fine. Don't worry, Sarah. Because Ashley was, Ashley was intending to be here, but I couldn't make it. So I'm a director at Orley and head of building performance. So me and Ashley work quite closely together. And on Wednesday, Ashley spoke to you guys about how MEP engineers need to respond to the climate emergency. And he started off by giving some background on the challenge itself, the scale of it, some of the history. He then went on to speak about the business case for reducing climate impact, or the impact of the climate on buildings. And then some practical tips on reducing energy demand and what you might need to do and need to look at. He then talked about focusing on the outcomes of the implementation measures that you make. And what to measure, and that linked on then to his final section, which spoke about verifying the performance of these buildings. And I think, having spoken to Ashley and gone through the presentation with him, the one part that really stood out for me anyway, and I hope it did for you guys, was this whole idea around the business case for making changes to buildings. And I think that the reason for that is because we've, as engineers, been working on this for such a long time. And we've got so far, but without being able to make this business case to the owners and developers of these sites, you just come up against a wall. So I think that's something that I would like to highlight from the presentation.
Okay, thank you. So that's a really great synopsis of what was very rich set of inputs this week. I'm now mindful of time, so I'm going to start to dive into some of our audience questions. So please keep popping those questions into the Q&A panel. And partly because I kind of have to, the first question comes from Dejan Mabovic, who's the boss. So Dejan asks, he's not really that kind of a boss, but it's a very good question. Dejan asked the question of all or any of our panelists, so people can feel free to chip in. If you were a policymaker, what would you do with regards to building regulations? Now that might be based on your research or your professional experience. And to my mind, you might have something very specific that needs to happen, a specific technical change to a particular regulation. Maybe we need a new regulation, or maybe we need to make a complete overhaul of our building regulation system. So based on research or experience.
I'm happy to come in, Sarah, just for kick it off, if that's...
Please.
Thank you very much, Dan, for an excellent question, Dan. Just briefly, just to kick it off, I think for many years, we and many others have been arguing that overheating perhaps wasn't dealt with as well as it could be in Part L, approved document Part L of the building regulations, and also the integration of the ventilation Part F component with Part L. I think, you know, for some time it's felt that there was scope to address that as well. So I think it's taken some time, but I'm pleased to say that that working groups have been set up, and I don't think they're finally reported yet, but having been involved in the ventilation one, I think it's very encouraging to see that MHCLG have now pushed that forward, I think, in two kind of key areas, which, I think, as I say, we and others have been trying to call for many years. I mean, the proof of the pudding will obviously be in what results at the end, but I think it's encouraging that that's now happened. So just to chip in with that initial first point.
Mm-hmm. I'm then going to go to Emma. You mentioned there partly about making the building case for the business case. Is there a point at which actually the business case gets made because the building regulations tell you that you have to do it, and so then that kind of sets the baseline? What do you see in terms of your clients and this balance between regulation versus better economic performance?
Sorry, I think my builder's shouting outside. Sorry, I don't know if you can hear that. So apologies. It just started. I think there's definitely, it's got to be both. I think what I found interesting about working in the operational building side of things, so, you know, I've worked in both design side and operational side, is that the regulations are quite strong in the design phase. You know, we've got limits and we've got targets and we've got things that we need to meet, and developers are very, very happy to design a building around that. The odd grumble here and there, but that's fine. What's bonkers to me is that when it gets to the operational side, there are no regulations really required for that. And so business itself has stepped forward. So we've seen the introduction of things like neighbours and design for performance come in from the business, from the commercial sector, because the regulations haven't really caught up with that yet. So it's almost in a weird way the commercial side is pushing the regulations that way. Now I think there is rumours around that there are going to be some limits in operational buildings put forward from the government. There's nothing published out there yet. So while I think, you know, commercial side is doing well and is trying to push it, I don't think it's ever going to get anywhere without regulations. I don't think you'll always get some, especially smaller and medium-sized developers, they will only ever do what the minimum required is.
Yeah, and Espan? Oh, sorry. Yeah.
And I just second what Emer said regarding operational staging. Operational performance is quite important to have either mandatory requirements for measurement and verification of performance in use, or a system of incentives, a proper system of incentive that works. Both for landlord occupiers, owner occupiers, but also in terms of speculative development, which is quite challenging actually, because in the latter category, it's a bit difficult to come up with a viable business case. So from market point of view, we see challenges in optimizing performance in use in that segment of the market. And this is something that I think policymakers would be able actually to help in terms of regulatory pushes for measurement and verification.
Thanks. Ian?
Well, I'd just like to add that this comment about buildings regulations ending up becoming maximum standards. I mean, they're meant to be setting out, in effect, a sort of minimum which you should try and improve upon. So I think that way of trying to incentivize better performance is what any new regulation should really try to target, rather than minimum compliance, which people just try to scrape by on with minimum effort. We've got to get a different mindset of better performance.
Yes, but is there a way that regulation can drive that mindset? How can we regulate to have continuous improvement?
Well, if there were regulations on outcomes rather than just the initial installation, that would be a big change. So in the performance, all the post-occupancy work that's been done shows that it's very hard to achieve the targets which are set at design stage, partly because the designers are not setting the right targets, but also because so much is lost during the process of construction and installation. So if actually you had to test a building in operation in order to get compliance, that would drive standards to improve.
Yeah,
difficult to carry out, perhaps, but as an incentive, that would be the right way to move.
Yeah, which links to Emma's point. Yeah. Oh, Florence, yes.
Can I
Let's
answer
hear
this?
about lighting regulations.
Well,
yes.
I wouldn't say specific about lighting, but if I were the policymaker, I really would like to sort of lean on technologies to get a better evidence of what we mean by outcome. So it's not an output of sort of measuring energy consumptions or anything like this. The outcome was the impact on people and how does it actually make a difference on a business term. So it's looking beyond just the engineering, but more of the real impact. And then you can use that and turn it into, so why are we designing something like this? Or even continue to think about technologies. If you embed all these IoT sensors in a space, how can we continuously learn from those data collected in use and use that constantly to optimize the system that is put in place? So I would really love to see, rather than that being a linear process of building regulation and you design according to whatever the standard says in terms of performance, is actually building in this loop into the system. And even as a participatory approach, it is exactly like that. It's a continual process of improvement. And people learn how they use energy less as well by being presented with some of the data and dashboard. It's bringing human into as part of the whole system design. And I think that's very important.
Yeah, with that kind of regulatory process, though, that sounds quite resource intensive. Would that then kind of increase the regulatory or enforcement burden if we're running a kind of, you know, these continuous participatory system feedback regulation processes? Are you talking about big government? Is that where we're headed for that?
Yes, it could be even as sort of a city level of the change. Okay. Yeah, city level of the change rather than the governmental level. And I think that's where the starting point is, where people learn, and then how cities actually learn with each other as well, because they'll be encountering a very different kind of climate change. And if we talk about temperature increase as well, how we going to learn to design for the changed climate. All these is everybody's learning process, but it's much more accelerated than what it used to be when nothing's changed over decades.
Yeah. Okay.
If I could just jump in there as well about regulations in post-occupancy occupied buildings, there's very little. You know, there is. You might feel like, oh, you're just adding more and more, but actually, there's nothing. You're starting from a very low base. Buildings actually run pretty badly in this country anyway. You know, and there's a lot of improvements that could be made. And so I think actually it's a gap that needs to be filled.
Okay, good point. Thanks, Claire. Yep.
Yeah, just not from a building regulations angle, but more from the policy angle. So I spend a lot of time at Public Health England, and you know, one of the biggest risks when we have heat waves is in care homes, large elderly populations and overheating. And you know we were hearing lots of reports that people in these buildings, that like the staff of the centres, didn't actually understand how the buildings worked and how to best regulate the temperature and things like this. So the policymakers, you know, they know that who's vulnerable, but there's a bit of a disconnect between designing the buildings, but then people knowing enough about how to use them effectively, as I'm sure you're already aware.
Yeah, which links to your point about all of these social and socioeconomic kind of you know, intermediaries between the physical risk and the kind of outcome or factors. And in that case in particular, it strikes me that it's, you know, as we've seen, the vulnerability or the atrocious lack of resources and attention that we give to care homes and the care sector in general. And so then it's unsurprising that people who are under a lot of pressure simply doing their job taking care of people are struggling somewhat to take care of their buildings as well. Yeah, Ian?
Just thinking on that, for a building in multiple occupancy or a public building, there have to be fire evacuation plans which are agreed in order to allow occupation. So you could imagine a situation where you have to have a well understood policy implementation of how to monitor energy and how to that people have to understand how to operate their building. I mean, it could just be a regulation that's required on occupation in order to occupy.
Yeah, and linking it to that kind of health and safety, and particularly public health and safety, is does seem like a, you know, fairly obvious connection to make. I'm now.
I'm sorry if I've.
Yeah, sure. Jump in.
Just very quick. It was just on Claire's point about care homes. It was just a very quick point to say that we've, after an initial pilot project, we've now started a project kindly funded by NERC, working with the regulator, the Care Quality Commission for care settings, and PHE and others to address really and to try, well, to think and hopefully be able to work with CQC, PHE and others to think about appropriate kind of guidance for, and I think it is a huge issue in that particular setting, type of settings, to to communicate clearly and effectively what are the ways that those quite complex buildings should be operated. So in terms of overheating in care homes, it's been something that Committee on Climate Change have been flagging up, I think, for quite some time now. So I'm really delighted that we've got the opportunity now to spend some time looking at quite a substantial number of care settings to and working with quite a wide range of stakeholders, including CIBSE, etc., to work on that project.
Yeah, and I would say, just as a colleague who's been kind of observing from a distance some of the development of that work, I think that some of the, having led on that work and being able to pursue it is something that I think as an institute we can take, I think, good pride, well, I think some pride in taking on what is a really crucial social issue that is, terribly overlooked and is of importance from a scientific and technical point of view, as well as the obvious outcomes for people's lives.
Very frustrating because we simply can't, of course, get into the care settings to undertake the monitoring work, but we did some initial monitoring work in the previous summer, which indicated, as expected, that the care settings were all overheating. Well, the sample that we had, and but we were unable to get in obviously in care homes this summer. But we're hopeful that one way or another, via a new contingency protocol, that we'll be able to do that. Anyway, well, thank you for the ways that.
Thank you. Yeah, so just looking through our kind of list of questions coming in, I've got one from Nahid. And so this question again is for anyone to kind of chip into. And it's about UK targets for net zero carbon buildings and the need to make them more energy efficient and integrate renewable energy into buildings in the UK. And there's been a lot of kind of recent policy announcements or ambitions in this area. And he's wanting to know if the panel thinks it's still the case that the government plans to have no boilers installed in new buildings from 2025. Where's policy at with that proposition? And then following on from that, how can we better integrate renewable energy for space heating into building standards and regulations if boilers are out of new buildings by 2025?
I presume this is a reference to gas boilers rather than any other sort of boiler. And I think there are other ways to heat buildings which are available now, and more will come on market as gas becomes in effect barred in new property development. So the use of, as the electricity grid decarbonizes, electricity is becoming a more viable economic source, especially if connected with ground source or air source heat pumps, for example, and it can be cheaper than using gas now. So I think there are alternatives. The government is also looking into hydrogen, which I know UCL have also looked at. I think hydrogen might not be appropriate for individual domestic heating, but it's certainly potentially more viable in transport and other settings, larger scale settings perhaps. But there's debate about that at the moment. But certainly there are lots of alternatives to using gas for heating, and we should welcome its demise.
Invest in heat pumps now, I think.
Yeah.
That's where the money is.
There you go. There's your hot stock tip.
Don't blame me.
No responsibility taken. Yeah, there. Seek advice from your own independent financial advisor. Yeah, Esteban, did you want to come in there?
And I just say that decarbonization of the national grid, as Ian said, is probably the single most important change that I have witnessed in my field of research in terms of improving energy efficiency. Of course, at upstream, high level, so speaking of integration of renewable technology, we have seen the impact of integration of renewable technology into our national grid. So the carbon intensity of the national grid now is less than half what it used to be only 10 years ago, significantly lower than that. And that's why actually it does make sense now to replace gas-fired boilers with heat pump, be it air source heat pump, with ground source heat pump. Of course, you can get better efficiency as well. So that is the direction of travel. Whether or not there's any mandatory requirement, we can see, we are on that pathway. Hydrogen infrastructure and hydrogen-based solutions are, of course, also viable alternatives now. But generally speaking, the trend towards electrification of building services is actually quite important. And in addition to energy efficiency, will bring us opportunity to shift loads. So demand side management and using buildings as load balancers. So to have an integrated, if you like, grid, your traditional power plants, but also your buildings as load balancers put together would enable us to not only improve energy efficiency, reduce greenhouse gas emissions, but also shift energy and make sure that upstream, the national grid is able to cope with the excess demand as we basically shift from natural gas to electricity. And this is, I think, something that we really need to focus in our research projects, and I can see several, ideas and research proposals emerging from this topic.
Yeah, so that also almost sounds like a question for our colleagues in the Energy Institute. This sort of bigger energy system demand. So yeah, so Emma, do you want to come in?
Sorry, yeah, I know you were, I'll just make a quick point about that. As somebody kind of who works on the ground, say, with all these things, I always find it fascinating about which sort of trends take hold. And as Esfan mentioned, the all-electric building has massively taken hold recently. It's huge now. And it seems every new development that we're working on, there's a request to say, right, what do I need to make this an all-electric building? How much more is it going to cost? What does that look like? So I think that's going to be massive, have a massive impact on it. And I think that's something that, the grid will have to react to. I don't know, people aren't sitting back to wait and see what happens to the grid. They're just going for it.
Yeah, so that I think there's a question coming in here. Someone was asking, or I think it's come from the chat. Apologies if you've asked this question and I can't attribute it to you, but moving from, and this is also the inevitable question that comes up in these discussions, is how do we move from retrofit, from new buildings into retrofit? And, is there a risk that if we went, so if I retrofitted my, took out my gas boiler in my 19th century mansion flat and heated that with electric radiators, that's driving up demand on the electricity grid. Admitted, yes, the great success story so far has been that's a less carbon intensive electricity grid than it was until very recently. But are we at risk of simply driving up demand by overemphasizing the benefits of, can there be an unintended kind of consequence there? So I guess I'm interested in any of the panel, particularly some of our industry folks. How do you deal with these kind of retrofit projects, and how do you relate a project kind of level decision to a system-wide, sustainability and carbon challenges like the status of our electricity grid?
I think it's going to be very difficult for individual leaseholders to deal with this, and I think it would be very much improved if the government decided to have funding available for wholesale area improvement, or to a particular property owner, freeholder, to do things across a range of units at the same time. Because first of all, you've got to understand the relationship between insulation and air tightness. You've got to find ways to reduce the load through heat loss before you then change, ideally, before you change the heating system. And it's very difficult to use heat pumps and electric heating in an unairtight, uninsulated property, because you just need too much energy. So I think that solutions for larger flat sets of flats need to be developed, which could be supported through some grant funding. I think would be very helpful. That's my first comment.
Yeah. And Espen?
Very quickly, yes, it's always important to start from basically the demand side and reduce the demand first before basically replacing the supply side. In this case, for example, replacing boilers with heat pumps. But also, I think there was a very important point in that question regarding potential unintended consequences for the grid, and that's precisely why this notion of load shifting and balancing is very important and comes into play, and also energy storage. So, for example, integration of electrical vehicles to the building services systems, the fact that we might be able very soon actually to utilize the electricity basically stored in battery when there's no significant demand on the grid, so that then we can use that electricity during peak time. So this type of strategies to shift the load is quite important to be able to cope with excess demand. Otherwise, this is an absolutely valid point. There is a risk that this shift towards electricity might have a knock-on effect on the grid in due course.
Thanks. Yeah, Emma?
Just on the impacts of retrofitting, there's a really interesting almost live case study happening right at the moment. So the Salix have released some funding for public buildings to decarbonise their heat. So this is money that's available to any public buildings, schools or universities or hospitals to allow them to decarbonise where they get their heat from. Now that funding is released, it's being released now. The deadline's closing really soon. Loads of buildings have submitted and have won that money, and it has to be spent really quickly. So in a way, we're very, very quickly going to have loads of data to see how easy is it to retrofit buildings to make them all electric, to decarbonize their heat. And I think doing some post-analysis on all that work is going to be really interesting, and actually will allow us to see what the pitfalls are.
Okay. Thanks. Right. So I'm now, in terms of our list of questions coming through from our audience, I'm going to ask one of Claire, which is coming in from Michael Corcoran, who's an EDE alumnus. And he's asking if you, would you expect to see an increase in climate-related mortality in the UK, taking into account measures introduced for decarbonisation? So electrification of heating, phasing out of internal combustion engines and so forth. And that was something that occurred to me actually during your talk, was the extent to which your projections around climate-related mortality take into account, my thoughts were more about adaptation. Michael's asking about mitigation of carbon impacts. So yeah, can you tell us how does that factor into your modelling and what your forecast would be?
Yeah, I mean, it's a good question in terms of actually calculating what the impact might be, because clearly it's not straightforward. And if, we we often don't know enough about adaptation measures, as in we don't know how the population will adapt to certain measures. But clearly this kind of measures to improve, to decarbonise, are likely to have quite a wide range of impacts which could be beneficial to health, and therefore you're reducing a number of risk factors at the same time. So if you can reduce the air pollution and make our buildings more efficient, then clearly you're going to sort of raise the bar slightly on the baseline mortality rate. So I think we know that fuel poverty is a problem, and it affects people's health if they can't afford to heat their buildings properly. So if we can improve buildings, then I think it definitely will have an effect. But the problem, one of the challenges, it's something that we're trying to address with the kind of multidisciplinary research that we do is to look at the impacts of various measures such as this, and to some extent we can we can look at how improvements can offset the kind of mortality, but in a broader picture of looking at mortality projections, we tend to use outdoor temperatures, and one of the biggest challenges is relating the outdoor temperature and the mortality of the population in general, which is a kind of epidemiological question, with the actual exposure of people who are spending most of the time indoors, and how this will impact on the numbers. So I don't have an answer to, I think it will help. Obviously these things will help, but I don't have an answer to how much. I can see that Mike is desperate to give the answer.
Yeah, over to you, Mike.
I haven't got an answer, but I was just going to build on your very good points there, Claire, and just to say that, yeah, I think these acts of energy efficiency interventions, for example, in dwellings, have a very complex and difficult, potentially to understand, implication for public health and across the housing stock. And we've been using our kind of housing model, which is imperfect, as every model is, but we hope it's useful in providing insights as to the impact on population health of these very large scale of energy efficiency interventions which are needed, and across these multiple determinants of health relating to indoor environmental quality as well. So a whole range of pollutants, but changes in temperature both during the winter and the summer, depending on where you are in relation to busy and polluted roads and what your window opening habits are. You can make certain assumptions and test out, I think, different possible scenarios for how the housing stock might be acted upon, both to reduce its energy and carbon outputs, but to also be adapted to appropriate to climate change, and then kind of test out what these interventions might have in terms of impact on public health alongside that. So I think there has been a wide body of work undertaken, both by us, but other people at other institutions. And I think there are some insights now which demonstrate that whilst there can be tremendous benefits of these interventions, both for greenhouse gas emissions, but also for health, there is also always just that kind of caution that there are these potential unintended consequences if care is not taken to reduce indoor environmental quality, both in terms of the concentration of the pollutants and the potential, at least, to increase the chances of overheating in summer as a result of these interventions. So it's not to kind of scaremonger and to suggest that that's inevitable, but I think it is certainly possible if these interventions are not installed or kind of operated properly. So I think that's been the kind of caution that we and others have been trying to convey to policymakers and others to try to design and implement these interventions as effectively as possible in an integrated way, which considers adaptation and integration and mitigation and adaptation, because you're really unlikely, I suppose, to be able to do these huge scale interventions to the housing stock more than one. So it will be very difficult and expensive anyway.
Yeah. I've got a question here coming in from Oscar Bruce, which I'm going to direct to Florence in the first instance, but others will be free to chip in. And the reason why I'm asking Florence is kind of in your role as a leader within ARUP, a global practice, and your own very international experience. Oscar's question is about the ways in which companies, possibly ARUP, there are other companies are available, but ARUP and others assess the life cycles of buildings and energy efficiency, both for current and future climates. But I think his kind of one of his interesting questions is, how can those methods be improved to allow more feedback, as you were talking also there, even when we're talking about policy and regulation, to allow for more feedback from the building and its surroundings, and in particular the local conditions in which buildings are situated and operated. So in some ways it's a kind of methodological question of how do we go from you know, what we hope will be a universal set of scientific physical principles, but making sure that the tools that we use to enact those are able to account for very specific local conditions. And then from a commercial practice point of view, how do you make, you know, a business out of that? So
that's a very big question there. So I think what might be describing there is the ultimate goal, to be able to do all those, but where are we starting? And just now I've been hearing, and I actually did say earlier before, that the focus on energy and carbon emission, we've done really quite a lot in sort of improving energy efficiency, dealing with renewables. We sort of know which direction we're going. What I've not heard much just now, but now this question kind of lean onto, is the embodied carbon. We save so much in the carbon in use, so what about the embodied carbon? So that's one part of it that is going to be huge still to find out. I think from a structural point of view, they've probably been looking into that, looking at concrete, timber, etc., for many years. So there is a framework that can do the calculation for carbon. But there's huge amount of building services that's going into buildings, the amount of aluminium, other components, some of them are rare earth components going to lighting, that's not really been looked at properly. How they're going to be recycled, but ideally not going back to recycling, but keep it in use for as long as possible. Maybe disassembling them and reassembling into some other application when a building get retrofitted or another building use. So all those need to be thought through. And this embodied carbon is very much part and parcel of how the life cycle assessment can be done. So that's one part of where the designers, the engineers could have the control of. And then there's the other part of actually working with other stakeholders in the value chain, supply chain, of how they manufacture, where they source those. How do they actually track and trace the various components that go into a product? From a lighting point of view, there's millions of different components that can come into play. And all those need to be in the calculations. So this framework, this methodology, as you said, Sarah, that still need to work through and ironed out and then we can bring all the data into place. Then one can actually start using those properly and assess it, because it depends on where the building is going to be. So the local context of climate, that's one set of calculation, but also where the products are actually sourced to service that building is part and parcel of that assessment as well. So this whole framework needs this system thinking, that because one is also dependent on others in finding that outcome.
Yeah.
And then when you look at a social aspect, this unintended consequence is a very important part that we actually need to start learning also beyond the engineering and scientific communities to actually understand the socioeconomic impact on what we do, because what we do in building will eventually impact the neighborhood and impact the broader region and cities. Yeah,
thank you. And I think your point about embodied carbon is super important. And I would say that outside of the IED, one of the most inspiring kind of movements I've seen in recent years is structural engineers who are really realize and are on board with the climate emergency and realizing that actually, you know, did the materials that they specify and the structures that they design, you know, are crucial as building blocks for responding to the climate emergency. Do we have any other thoughts from our panel on
I'd just like to add
global methodological problem?
Yeah, the international style has had such an enormously bad impact across the world, and I think the issue here was one that we've got to take note of, because this was an attractive proposition based on endless energy availability and a cultural lifestyle that was being sold. People around the world then decided, oh, let's appropriate this culture. We want one, and the international style of basically concrete frame buildings with very inadequate overglazed facades has had an enormously detrimental impact. And it's exactly what we mustn't do now. And I think it's generally recognized that that is not what we must do. But the way to counter that is to think about the local culture, the local climate, and learn from local historic buildings.
Okay, thank you. So we're now down to our last 5 minutes. So I'm just going to ask each of the panelists in less than a minute for their last thoughts. And in particular, what do they think we need to be thinking about in terms of the next 55 years of environmental design and engineering? And because he smiled at me the wrong way, I'm going to go to Mike first there.
Thank you, Sarah. Just a very brief one, really. I mean, given the time left, I think I just really wanted to maybe make the point that over that long period, we and obviously many others working in the area have hopefully learned a lot and learned a lot about possible solutions. And I think really, maybe to reiterate what others have said, that really what we need now is to really start to rapidly implement these learnings and findings at scale and in an integrated way. So basically, scale, pace, and integration is what I think, and is absolutely required now. And we've learned a lot. We now need to start implementing it and understanding how best to implement it at scale and in an integrated way.
Okay, thank you. Espan.
I look forward to the realization of net zero carbon targets in use, basically. It's a very challenging and ambitious target. I think the technical know-how engineering solutions are there. It's a matter of integration, optimization, but also tackling, I think, the challenge of fragmented construction supply chain, which has, I think, been detrimental over the last years and decades, really, and has been a real barrier in terms of achieving design intents in practice. So it's great. We have all these targets in place now. I mean, the government now has committed to even more ambitious targets by the end of, I think, this decade, 2030. This is great. We talk the talk, but we really need to make sure that the framework system of incentives and basically new, or if you like, improved regulations are in place to facilitate this transition. It's a big challenge.
Great, thank you. I'm going to stick with the internals first and then move to our external participants. Claire?
Yes, so I think it's important that although we know more about what measures that we can implement, I think we need to continue to learn from other disciplines, because we're not going to find out about these kind of sort of compounding potential issues that we might come across, and that's something that I think we're doing within the department quite well, and I think we need to learn from international colleagues as well, that learn from past experiences to ensure that we just maximise the benefits and make sure we don't run up against any problems in future.
Thank you, and now I'm going to head over to Emma.
So what I'm most excited about, I think, for the next 55 years is seeing this shift from a profession, building services engineering profession, of being like a technical, something that's focused on the physical aspects of building systems and how they interconnect with each other and the science behind it, to a stronger focus on the psychology of the people that use that building. So I think, the engineers of the future are actually going to be part engineers and part building user psychologists. And I think that's really exciting for me.
Great, thanks. Ian, your thoughts?
Well, it'd be very sad if in 55 years someone picked up an architectural magazine that was full of net zero carbon design and it hadn't happened. So we've got to be optimistic that in 55 years it will be a thing of the past, this issue. We'll be debating, everyone will accept that the world is only made up of what's in the world physically, and that has to be reused. There's no more worlds, so we've only got one. And that the whole idea of regenerative design and biophilic design will become something which is taken for granted, and we'll be thinking about how to improve the world through what we do rather than destroy it.
Yes, thank you. And I am also, as an environmental engineer, share the ambition of doing myself out of a job before 55 years. And the final word to Florence.
So 55 years, I think the students will need to see what this moonshot looks like. So what we really mean by sustainable future. And we've heard all the presentation, what it's really directing to is we need systems thinking beyond what we have been calling just interdisciplinary approach. It's a lot more than that. So we need UCL, IE, and academic environments that's there to show the students how to get to the moon, and nurtures and encourages this kind of experimental thinking, so that our next generation of building professional can learn not only the domain knowledge, but also explore how new materials, technologies could be used, and they can sort of really develop this transdisciplinary way of working. Regenerative design is about reversing the damage that has already been done and seeking new ways, novel ways of allowing ecological system to regain and maintain a healthy state as we progress. So all these will require system thinking to be embedded in a design process that have to be inclusive and collaborative.
Great. Well, thank you very much. That's a really great note to end on. And I'd just like to say thanks once again to all of our panelists for your fabulous contributions, not just to this session, but also to the earlier sessions. And thank you for our audience for your questions and participation throughout the week. All of this presentation or this discussion and all of the presentations will be up on the IEDE YouTube channel. So we hope to see you there. Thanks.
Thank you.